inverse functions. They've given us this function, and this is a quadratic, and it happens to be in vertex form. Our a value is 1, an h, and a k, right? The inverse of this, especially in function notation, is written as f to the power of negative 1. And one way you can think of an inverse function is f at x. A lot of times if we were to graph, we would replace it with the value of y. And sometimes this is a little easier to work with an inverse function. Let's say I replace f at x with y. So I'm now writing the exact same function, just it's set equal to y. Okay? What I'm going to do from the next step is oh, sorry. Okay, let me just highlight these for a second. Our y and our x, you're right, it is plus 4. So change that to plus 4. Our y and our x, to solve for the inverse function, we essentially can replace or exchange the positions they are in the equation. So I change this to being equal to x and the y in its place, and then I reset equal the equation to y. So our next step here, I then have x is equal to y plus 4 squared plus 15. Okay, so if you've noticed, we've changed their positions in this equation. But in order to set an equation for us that'll be easiest for us to graph, we want to set the entire equation equal to y. So now that I've, you could say, inverted or changed the position of the two, I set this equal to y, this equation. So my first step will be to move the positive 15 to the other side. So we're left with x subtract 15 is equal to y plus 4 squared. Okay. Now I need to get rid of that squared, so the operation is to square root both sides. And you guys have dealt with root functions before? Yeah, okay. So the root of x minus 15 is equal to y plus 4. And the last step here is to really just move that 4 to the other side. We have the root of x minus 15 plus 4. And this...
Minus 4.
Oh, sorry, thank you. Minus 4. This would be the inverse. So f at x inverse is equal to the equation of root x minus 15 subtract 4. Okay, and remember an inverse function, if we were to sketch it, like a rough sketch, okay, and I do have we are in vertex form, so we can make a pretty good estimate here of what this will look like. It'll be at negative 4 plus 15, so we have something like this, okay. The inverse of the function is actually flipped on a linear equation of x equals y, like a 45-degree angle. So we have an idea that we're probably going to be looking at something like this. And if you remember your transformations of functions, the kind of apex of this root function are at negative 15, so at 15 and negative 4. And if this is at 4 and 15, this vertex of this quadratic, 4 and 15, it would make sense that this point here would be at negative 4 and our x value being 15. So we've switched these points here. And we can even show that on our program. I think we have it here, decimals. Okay, we'll hide these little functions we were working with earlier. Our equation read x plus 4 to the power of 2 plus 15, I believe. And we'll just zoom out a bit. Oh, sorry. Plus 15, that makes more sense. And then our next function ended up being the square root of x minus 15 plus 4. And because they've written it like this, just because it's to be a function. If we had written the other part, then we wouldn't have a function. So they've only used that part of the equation there. Okay, so let's just take a look at the entire thing here. And that's essentially it.